Hi everyone! I'm hopeful you can see me, I'm hopeful you can hear me. Fingers crossed on all of this. My name is Cami Williams. I am a Facebook open source developer advocate, and this is part 3 in our live streaming series on how to connect your web application to a PyTorch model using AWS SageMaker. Woohoo! Yay! I've gotten a lot of comments about the video resolution in previous videos, so I think I fixed it. I'm hopeful I fixed it. If I didn't, I apologized. I am completely open to suggestions on this. Please comment down below if you have any good video tutorials that can help with the resolution, but I'll do my best. Again, I hope I fixed it. I'll zoom in. Please feel free to tell me if you need me to do it more. Like I said, my name is Cami Williams. I work for Facebook. I work really closely with the PyTorch project, but I also previously worked at Amazon, and so I have some AWS know-how. And I wrote a blog post recently about this. Let me switch over, which I'll share with you in the chat. It's essentially a blog to follow along with this video series. If you're curious where we're at right now, we're following this diagram. So essentially with hosting a PyTorch model, it's a neural network. It's a way for you to recognize different things using machine learning. We are using the MNIST dataset, which is a dataset of handwritten numbers that allow you to take in an image and then give back a number to the digit the neural network thinks it is. So we trained our PyTorch model and tested it and built it, and then we hosted it on AWS SageMaker. It's pretty intuitive, but it's essentially a place on the cloud where you can host these models. It has GPU support, TPU support, so if you're curious about it, please feel free to check out the first video. In our video last week, we then deployed our SageMaker model and connected it to a Lambda function. This Lambda function will essentially take the information, give information to SageMaker to put through our model, and then take information back. So we have this Lambda in front of SageMaker to essentially parse the data so that way it's ready for the model, and then to take in data and parse it from the model to eventually send it to API Gateway, which is what we're doing today. So with API Gateway, we'll take the functions of that Lambda service and we'll apply a REST endpoint on top of it. Applying this REST endpoint would then make those functions accessible to any front-end application. We're going to be making a web application. So like I said in this video, we'll be diving into API Gateway, and it will be our last step of using AWS. Woohoo! We're almost there. So hopefully we can get a lot of that done today. I think we will, and then we'll start building the web app. And then in our video next week, assuming all goes well, we'll finish up the web app, and then I'll be able to share this code with you. Although we haven't done too much coding so far, it's been pretty lightweight. For those of you wondering what we are building, we're building a digit of pi PyTorch recognizer. So this is a GIF. It is pretty low res, so I promise I'll show higher res things, but essentially I'm going to create this canvas that you can draw numbers on, and then the numbers will appear on the right side. Again, all of this is in the blog post, so if you prefer reading versus following along with video, you can check it all out here. So I'll show you really quick the different things that we have done thus far. So this is our AWS console. We're in SageMaker right now. We created something called a notebook instance. This notebook instance is essentially where your model is trained, tested, defined, and how it'll take in, and how you can interact with different functions on that model. So if you click on Open Jupyter, you can see all of our files here. Mine is currently running. This runnable.ipynb shows our neural network is running and it's taking in requests. Our neural network is defined in our mnist.py. And then we have a canvas that we defined in our input.html in order to test this neural network on handwritten digits. So all of this code is actually, let's see, let me find it here, in this GitHub repo. So I'll share with you this GitHub repo so that way you can take it out. We're just following this tutorial, but we're building on top of it. So I'll quickly show you what we can do with this runnable file, just as a refresher. So this is where we train and we test our neural network, hosted on S3. This is all our neural network code. It's essentially defining what type of images we can take in and the data that we'll give back. This is where we train our neural network. We have different epochs that we go over that help us increase the confidence of the neural network being correct. So when you feed data through a neural network while you're training it, if you are following along with us, you have an image, which is the image of the handwritten number, and then a digit associated to it. And so when the neural network trains, it's able to, take in the image, give back an output number, and then you can get a confidence as to how many of those digits it gave back were correct versus incorrect. So we got 97% accuracy, which is good enough for me. If you want to get it even more accurate, you can increase the epochs here. We did 6. That's just the number of times it trains the model and optimizes. But this is our input.html. So if you can see, we'll draw an 8 here. So this obviously opens that HTML file. That HTML file is a canvas. We draw the 8 on it. Then we can convert the image to data and then run it through our predictor or our neural network and then get a prediction. The prediction will be an array. Each digit of that array will represent the digit it's associated to. So if we get a higher number in the third place in the array, that means that the neural network thinks that the number that we just drew was a 3. So I'll quickly run this, and you can see this is the output of our image. It's a multi-dimensional array. If we format the image a little bit, it's kind of hard to see, but if you follow the outline of the ones, it looks like an 8. This is the one we did last week, but you can do it with any number. This is the output from the actual neural network though. So this first multi-dimensional array is the information we give the neural network. This second one is the information the neural network gives us. And as you can see, the highest number in this array is in the 8th position, and so it is associated to the number 8. I can do it again with, let's say, a 3. We'll run this on the 3, and same thing, it gives us the 3. So this is all in SageMaker. We then moved to Lambda. This is our Lambda function to be able to access this information and do stuff with it. If you can recall, this Lambda function is what will send appropriately formatted data to the model and then get that information from the model back. So this is what our code looks like. Let me move this down so we can see it a little bit. So we have this environment variable called endpoint. This endpoint refers to our SageMaker endpoint. We're using the SageMaker library. We then would take in an event. This event, as you might be able to imagine, will be the JSON that comes from that API call, which we're going to create next. And any relevant context for us, we don't really use that, but we take the event and we convert it to programmatic JSON. And then what that JSON kind of ends up looking like is this data, and then in curly brackets we have image, and then the image is our multi-dimensional array. So we set the payload equal to data, which is essentially just this image in brackets. Then we invoke our SageMaker endpoint by sending it that payload data. We get a response back and we decode it. We clean up the response by getting, so what comes back in that response is that array of size 9, so 0 to 9, or of size 10 with indices 0 to 9, I should say. So then we get the maximum of that array, we print it out, it becomes our predicted number, and we would return that predicted number. So in the REST call, we would send this event, and then the response we would get back is predicted number. Hopefully that makes sense. So let me show you what this looks like from a testing perspective. So I'll quickly, let's see, we can just do test 3. I'll configure the test so you can see. So we have that data, and this is the multi-dimensional array. This is a 3. Again, we did this last time. So if I click test, then you can see our response is 3. Woohoo! And we don't get any errors. I can check out the logs to see my print statements. So this is going to be in AWS CloudWatch. So every Lambda function has a CloudWatch associated to it. So I'll load this. Takes a look at the log streams, which is essentially how many times this Lambda function has run in the past. If I click on that, then we can see that the payload comes in as that multi-dimensional array. This is the array that the neural network gave us back. So this was a 3, so if you can tell 0, 1, 2, 3, this is the largest number. Again, on the SageMaker side, I could take this array and format it a little bit to look like actual percentages, but this is good enough for us for what we're doing. Because this is the 3rd index, then we know that this number is closely associated with 3. Yay, we return 3. Oh, yay, your videos are really helpful. Thank you so much. I'm so happy that this is helpful to people. I have a lot of fun doing this. I like kind of connecting these two concepts and bringing it together. So I'm glad you all are enjoying it as well. Let's do another test case just for fun. I will do a number 1. So we'll see if it can recognize this as a 1. It's looking a little rough, but oops. I erased it. All right, there's my 1. So I'll run it. Oh, it thought it was a 2. I guess it kind of looks like a 2. Again, so if you look at the 1 and the 2 indices are pretty close to each other. It also kind of thinks it's a 3, but it got close. Let me just do it like this then. A 1. So now it's a 1. So that's a case where you might want to train your neural network a little bit more, or create your own images to run through it so that way it understands how you draw. I don't really care that much, so this is, like I said, it's good enough for me. So I'm going to take this this array, this multi-dimensional array, which represents this drawn image, and just put it through Lambda so you again can see what our test looks like. So I'll create a new test. I'll call this one test 1. I'll paste in that multi-dimensional array. So if you can imagine on the website, on the web client, we'll have to have a similar canvas, which is why this tutorial is so helpful, because they already give you the code for the canvas. But then we'll have to convert that canvas image to an array and send it in the API request. So I'll paste that in there, and then create the test, test it, and our response gave us a 1, exactly as we thought. Great, okay, so hopefully that overview makes sense. Now we're going to head over to API Gateway so we can take this Lambda function and wrap it in a API. Okay, so like I said, we're using a service called API Gateway. If you're unfamiliar with how to find it, if you just go to your AWS console and search under Services API, API Gateway will appear. So you go ahead and click on that. And then you can start to create different REST APIs. We actually utilized a blueprint. Oops, let me go back. We utilized a blueprint, if you can recall. A blueprint is a template. When we were making our Lambda function, which already set it up for us. It was the microservice HTTP endpoint Python template, I believe. So in doing that, not only did it create the Lambda function for us, but it also created this API Gateway REST endpoint for us. So if you did that blueprint, then this should already exist. If you didn't, then you can click on Create API up here. Something else to note too is in creating that blueprint, we also updated our IAM permissions to be accessible to API Gateway. If you're, again, unfamiliar with AWS, almost everything has an IAM role associated to it, and that role has permissions that gives that user, if you want to call it, a access or permission to use different Lambda or AWS services, Amazon Web Services. All this to say, if you need help updating your IAM role so that way it has access to API Gateway, you just go to your IAM role, click on the one that you're currently using. I think I'm using, this one. And you would click on Attach Policies and then search for API Gateway. And I have been invoking full access to all of these. You can see that we already have it here, but I'll just attach it again for fun. I've been attaching full access to all of these. If you want to deploy this code to production, I would suggest doing some research on IAM roles so that way you know where and when to give the proper permissions. But again, because this is a demo, I just do full access and that's good enough for me. Okay, so back to API Gateway. So we have this endpoint already created. I'm going to go ahead and click on that. And you can see we have our methods for this function. We have any right now. I'm going to go ahead and, not right click. I'm going to delete this method because I want to get a little more granular here. I don't want to accept anything. I'm just going to actually accept post requests. So I'm going to delete any just so we can start from scratch. So everybody's on the same page. Okay, now we'll go back up to actions and then click on create method. And from this drop down, you can go ahead and select post. Hopefully, again, this is in higher resolution. Hopefully all of you can see this. I'm trying to narrate it as much as possible just in case anybody's following along and it's blurry. Fingers crossed. Hopefully y'all can see this. Okay, so now we have our post setup. So we want to select a Lambda function as integration type because we want it to be connected to our Lambda function. In order to accomplish that connection though, if you can recall when we were looking at SageMaker, we had to copy the ARN and assign it as an environment variable so that way the Lambda function knew which SageMaker instance to talk to. Same is true for API Gateway. I'm back in my Lambda function here. I have to copy this ARN on the top right. So scroll all the way to the top. It's on the top right. Click on this copy button. And then going back to API Gateway, I'm going to paste it under this Lambda function. And you can see it shows up here. You can just click on that and it goes to the name. If you have a lot of functions, especially if you use AWS a lot, it's just easiest instead of searching for the function name to attach it to the ARN. Cool. So Lambda region, just ensure that the regions are consistent. You don't have to select the proxy integration. I don't actually know what that is. If anybody knows what that is, let me know. Leave a comment. But then when all of this is done, default timeout is fine. You can go ahead and click save. I'm going to give this API Gateway instance permission to use my Lambda function. Yes. And then we are going to create it. So, okay, once we've created this post endpoint, this is what the communication flow looks like. So if you are testing with API Gateway, you can kind of test at different points in this communication flow. So as you can imagine, this is the client. This is where the requests will come from. Method request goes in, integration request goes to the Lambda. Lambda does something cool. Lambda sends an integration response. That gets converted to a method response and then gets sent back to the client. So this communication flow is pretty nice. You can set up different access controls with all of these too to make it a little bit nicer. And API Gateway is meant to point to a Lambda function, which is kind of why we need to have that as an intermediate step before we talk to SageMaker, just because this REST endpoint has to touch Lambda. Okay, so next we want to click on Actions and enable Coors. So when a web client accesses this API, the way different APIs work is sometimes you need a user-specific token in order to get permission to access certain data that the API provides. For me, similar to I'm just going to make it completely open. If you are creating a web application, mobile application, anything that uses this REST endpoint, you might want to make it less accessible, because this is where the bulk of my AWS costs will come from. As requests get sent to Lambda, as you can imagine, the model is going to be utilized much more. So if I'm sharing this API endpoint to the masses, this is kind of where I would want to set those restrictions or permissions. Again, I'm keeping it open for demo's sake, but if I were you, I would revisit this if you're going to use this code in production. Okay, so there are different options, as you can see. I'm going to update the following headers. I think this actually probably looks good. So this is, again, setting what people are allowed to access when they utilize my API. So it's important to do content type, date, authorization, API key, security token I don't want. Okay, so I'm going to actually delete this. And I am adding x-requested-with. So, and then a closing single quote. So you have content type, you have X, Amazon, AMZ, date, you have authorization, you have X API key, and then you have X requested with. For access control origin, I'm keeping it at star, meaning I'm keeping it completely open. You can go ahead and click advanced. There are other things that you can add to these headers, credentials, whatever, but this is good for me, so I'm just going to click enable Coors and replace existing Coors headers. Cool. So yes, I'm going to update this, so this will just summarize exactly what you are converting to or what you are opening your API to. I'm going to drink some smoothie because this is my lunchtime. Okay, so we're good to go with permissions now. Now we want to actually interact with the post function. So go ahead and click on post on the left, and you're going to select method response. So this will essentially be how we send the response back. So method request, we will take in anything basically. Integration request, again, will take in anything. We can send an error back. It'll probably just error back if they don't give us that message, which is fine. I'll just take the default error. But I'm going to go ahead and click on method response. So we see this HTTP status of 200. If we click on the dropdown, we want to see a couple things. So we have this access control allow origin. We want to update it according to those Coors permissions that we had already set. So I'm going to add a couple headers. I'm going to do X requested with for my first one. Again, this is what we got from Coors. I'm going to do access control allow headers, so we're allowing all headers to come through. Control with, I'm just making sure I'm spelling it all right. And then allow methods is the next one. So we again have those 4 things that match what our Coors capabilities were. So this should be good enough. If we were sending over more data, like that access token that a user might be requesting, we would have to do a little bit more. But this should be good enough for me for now. Essentially all I did was I added this post request and response functionality on top of my Lambda request, and I opened it up to accept and send anything. So with that, now we can test it and see if it actually works. So testing this API gateway is going to be similar to how we tested our Lambda function. I'm going to want to get that big multi-dimensional array. So let's just see how it looks. Okay, so when you click on test, sorry, let me show where. So on the client side now, I think that the communication is done. So I'm going to click test, the communication path, I should say. So I'm going to click test. So I can go down to the bottom, and in this request body, this is where I will send that multi-dimensional array. If I just click test now, I get an error because it is looking for data. This error I should probably make a little bit more interesting, which we can again clean up later, but it's erroring out. I wrote the code, so I know what it means. As you can imagine, I could put an if statement here and then return no number found or no image found or something, but we'll do that later. In the meantime, I'm going to get this test event that I took from Lambda. Cancel that. So I just copied that, and I'm going to put this in the request body. So we have data, we have the big block of numbers. I'm going to click test. This should be a 1, I believe. And we got 1. Woohoo! So now we have our API built on top of it. We can do some cleaning up, but essentially, and we can do some playing around, but essentially this is all we need. So we need to deploy this API once we're done testing it. I can do a couple more tests just for fun. Let's do something that the model has never seen before. We'll give it a 4. So I'll run it. Thought it was a 5. Let me try again. This is why, again, you know, training it might be a little bit better. I'll copy this 4 over. Paste it into API Gateway. Test. We get a 4. Yay! So we have to deploy this API endpoint. It might take a second. I'm not totally sure. I don't think it's going to take very long. But once you've tested it and it is to your heart's desire, you can go ahead and click on Actions and then click on Deploy API. Again, I can clean up various things in the Lambda function and here, but deploying this API, if I edit the Lambda function, those updates will be seen in the responses. Deploying the API is essentially just deploying these permissions. So I'm going to go ahead and deploy it. Deployment stage, default, new stage, you can call it, do whatever you want. So if you do a new stage, you can name it. So for fun, I'll just name it prod. Description, the endpoint is ready to party. Let's run this. Deploy. Okay, cool. So now it is deployed and we have this prod URL. So at this point, again, if you cared, you have this URL. You could do some URL mapping using various services. I'm not sure if AWS has one, but to make this prettier. But this is the AWS URL that I will use. so we can test it if you want. Let's just test it in the web inspector console. Ooh, gross. Okay, let's clear it out. Okay, so we have our URL. Now we'll just do a REST call, API REST call, yeah, in JavaScript. So I, again, am in the web console. I'm just testing right now to make sure that this endpoint works. So I'll just do, let me zoom in here. So I'll do let URL equal to this. Let me get that payload here. Let's see, wait. Yeah. I'll do that and go back here. I'll do let image array be this. Okay, so now we have the image array, we have the URL. So I'm going to make my payload. So set payload equal to data no, sorry, go back. Image, that's how I did it, right? I'm essentially just copying what that test looked like, which was, I believe, just like, yeah, just data, actually, not image. So let me go back. So I'll just set data equal to, actually, oh my gosh. All right, let's try this again. Okay, I'm setting my URL. Yep. Image array. Yep. Let payload be equal to data at the image array. So payload should be, yep, my JSON. Okay, so now I have my variables I need to make my request. So I'm going to do response. And this is again in JavaScript, so I'm going to use an await. Fetch. So I'm fetching that URL, so I'll do URL. And then add a couple things here. So when you are, can I move this up at all? Okay. So I want to call that URL now. So I did fetch the URL with the following properties. We're going to use post. This is just standard JavaScript. In my body, I'm going to do JSON.stringify my payload. Let the request know that the data type is JSON. And then define my headers. So this header needs to correspond with the headers that I allow to be incoming in my API properties. So I'm going to do my content type be application JSON. Okay. This. Oh no! Refuse to connect because it violates the content security policy derivative. Shoot. Okay, this is what I was trying to avoid. Sad. So, this is an error I get a lot with API Gateway, and I was clenching, hoping I wouldn't get it. But it's essentially something with the Coors policy again, where I've been blocked by the Coors policy. I'm probably going to have to Google how to fix this. unless somebody knows how. So it's been blocked by my Coors policy. Response to the pre-flight request doesn't pass access control check. No access control origin header is present on the requested resource. Poop. I thought that that's what this accomplished, but maybe it didn't. Let me see what happens if I just do that. And same thing. No access control origin header is present on the requested resource. Okay, let's Google what that means. And hopefully something comes up. Okay, this one seems interesting. If access control origin is in the response, then browsers will relax that the blocking on the blocking and allow your code to access to the response. So, if you send your request through a Coors proxy, I don't want to do that. I just want to update my API gateway to be okay. API gateway. Here we go. It's a common problem. I have used 10 hours to find it out. Okay. Response. Oh, okay. So it looks like I probably just need to add these. That would be so nice if that's the case. Let's switch back and see. Ah, no. Shoot. Oh my gosh. Ugh. So I'm going to that, paste. Maybe this will work. Requires support to work. Required for cookies to work. Hold your breath, folks. I need to enable Coors origin in the API. Oh, I thought I did that. Thank you for the suggestion. I thought I did that, but I am going to double check. Enable Coors. Content type. Date authorization. Security token. And then in the post, in the method response, access control allow origin. So just do a star there? Is that what you're suggesting? Wait, no, this is in Coors. Yeah, access control allow origin, star. What am I doing wrong? The following modifications. Okay, sure, why not? Let's try it again. Deploy to prod. We'll see. I think I did it already, but maybe everybody needs a gut check. Hey, Ish, thanks. I really, really hope this works. Shoot. Access control origin header is present in the requested resource. I'm actually very informative. Thank you. Okay, let's see what else it could possibly be. I think I know I've hit this problem so many times. It's definitely something with my permissions, which is a bummer because, again, permissions. Access control allow origin. Access control allow headers. Access control allow methods. Yeah, I think that's all I need to do. Requested with access control allow headers. I'm just double checking my spelling at this point. Access control allow origin, access control allow methods. Good. Now enable Coors. Access control allow origin is a star, which is what we want. I'm just gonna paste something that I have in the blog post, and maybe this will be beneficial. Yes, replace. Yes, deploy. Okay. I don't think that made any difference, but oh shoot, did I close it out? Oh, I'm such a fool. Okay. Let's see if anything was maintained. Still nothing. Still nothing. Okay. Back to the Google machine. So, actually I need that open. Anybody else have any suggestions? Totally open to them. Okay. Wait. Oh. Okay. No access control origin header is present on the requested resource. Let's Google this. With API Gateway. Enabling Coors for a REST API resource. Fingers crossed. Okay, so we definitely want to do that. Includes an origin header. Includes the options method. Access control request. Access control allow. Those three things. Oh, okay, maybe that's it. So we did it for post, but we didn't do anything with this options thing. So we probably, what? It's there though. I'm just going to make sure that there's consistency. Requested with, change this to next. And then enable Coors here. No headers. Let's try it again. Okay. See, I thought that maybe we would get this one and done in this amount of time, but I knew that we would come up with this error. I always have such a hard time understanding how to fix it. Enabling Coors for Lambda or HTTP non-proxy integrations. When you enable Coors using the AWS Management Console, API Gateway creates an options method and an attempt to add the access control origin header to your existing method integration responses. This doesn't always work, and sometimes you need to manually modify the integration response to properly enable Coors. Usually just this means manually modifying the integration response to return the access control allow origin header. Okay. Do I need to enable Coors support? Question mark? I don't think so. I shouldn't have to do that, I don't think. Okay, let's dive into something else. Coors with custom credentials, Coors with cookie credentials, access control origin, nothing. My laundry just finished if you can hear noise in the background. Cloud Guru, again, totally open to suggestions here. I'm going to finish this by the end though. I forgot to check the use Lambda proxy integration. It appears this needs to be checked so some data is passed to the Lambda function. I didn't check that when I first did this, but maybe it's something that you actually do have to check. I teased about it. Short answer, you probably used other regions. Nope. That's not it. Okay, maybe we try that then. So I'm going to kind of tear down the fourth wall or whatever it's called, and take a look at my one I did before that I think works, and just double check certain things. So I wrote this before. This is exactly what we wanted. Access control, allow origin. Access, I'm just gonna make sure that I spelled it right. Allow headers. Oh, wait a second. Did I do something wrong? Wait. Okay, I think I might actually know what this is. I don't think I did anything wrong. See how I have this slash? And then see how I have this maker PyTorch Sage function? So if we go back really quick, sorry, I'm just showing examples of something that works and something that doesn't. I think I did this wrong. So this slash with just a post versus the other one with the function name and then a post, I think that's why it didn't work, is because I wasn't referencing this maker PyTorch Sage function thing. So if I go back to, yikes, to the URL, I think I have to do slash maker PyTorch Sage function. Maybe. Let's try it. Payload is not defined. Why? I thought I did define it. Image array is not defined. Dumb. Image array. There's my image array. This is what happens when you close things. Payload. My URL is defined. It's gonna work. Violates the contents policy security directive. Okay, so we got something else. It definitely isn't right, but we got something else. It violates something. That's exciting. What is it? This is, okay. Actually, this is how I solve things. I just keep trying random things versus reading and hoping that it works. Request header field access control origin is not allowed by access control headers and pre-flight. Okay, whatever. I like the other one more. Violates our content policy security directive. What the heck does that mean? Oh, wait. What? Undefined? Wait, did it work? Wait, response. Did it work? Yes? This worked. So, okay, let response JSON equal to await response.json. Await response.json. Okay. Wow, fam. Response JSON 3. Wow, okay, it worked. Okay, so what was the problem? Stupidity. Not really though, but hey. So when you deploy your API, you have to do /maker PyTorch Sage function and then run it. This was my own stupidity. I forgot to put this in the actual URL, but now it works. With this, intuitively, you can have different endpoints in your API, so I can have this point to different Lambda functions or different parts of my Lambda function, and it'll work. Wow. Okay, so great. We created our endpoint. Now we can actually write some JSON code to make this happen. I'm going to do that right now in the 8 minutes we have left, just to show you that this is working and that we can use it locally on our machines. Yay, thank you guys. I appreciate you sticking with me through all this. I was nervous that I wasn't going to be able to figure it out, but we figured it out. Okay, so IDEs. Feel free to fight me. My favorite IDE is Sublime. I always use Sublime. I'm not a Visual Studio person. I apologize if you are. Okay, let's make a random thing. We're going to make a really quick HTML page. I'll call this, let's see, I'm going to just create a new folder. I'll call this SageMaker PyTorch Fun. And we'll make this my index.html. Woohoo. I'm going to go back. No, I'm not going to go crazy right now. So we'll have this index.html. I'm going to create my JavaScript file. I also am not a front-end developer, so if you watch me do this and cringe, or if you've been cringing this entire time, nothing is new. I'm just going to try my best to write JavaScript, so please don't be sad. So I'm going to create an async function to do my JavaScript request to, so I'll just call this main.js. Sure, why not? We'll call this function send post request. We'll take in an image array. Oops, image array. I'm gonna copy over that code from my dev console. Hello. Paste it in there. So what do we need from this? We need my URL. And that is this guy. Yes, I want this. I'm just copying this over. So URL is URL. payload is my JSON data and then my image array. And then I stringify my response, so let JSON response be equal to my response.json. I do a wait because I'm waiting for the response to be populated. And then return JSON response. Boom. Okay, so now we have our function with the post request. Do I want to create a quick web page to be able to capture all of this? Yes. Okay. So, do I? Let me just head and then body. I'll do blue. Now I want to link the main.js to my to my index.js. I don't remember how to do it. Again, intro here. Link JavaScript to. How do I link my JavaScript file to my index.js? Script. Source. Shout. Wait, is that actually how? That doesn't, why does that look wrong? Connect JavaScript. Did you guys see my autofill? It was connect a PS4 controller to your PlayStation. You know what my hobbies are. Yeah, it's this. Why does that look wrong? I don't know. Not that I would know. Okay. So main.js. Save. Let me open the thing. So this should, yeah. So this should just say hello. Okay. So then I forget if I actually have access to this, but what was my function called? I don't think I do, but maybe we do. We do. Okay, so now if I just do send post request and then that image URL, up here, boopy doop boop, get out of here. And enter. Now we have a promise. Oh, how do we actually run the promise? Oh, I have to, okay, let poop be equal to this guy. Wait a couple seconds. Poop is a promise. How do we get stuff from a promise? Promise status fulfilled. What's in the promise? Promise, then. Well, shoot. I need to look up how JavaScript promises work. Dang it. What did I even return? Oh, I returned the JSON response. How to get info from JavaScript promise. We have 1 minute to do it. Then. Okay. Poop.then is a promise. Poop.then is 3. Okay, it's 3. You can see it right there. Res.json. Poop.json. Poop.then.json. Whatever. You get it. All of you get it. The 3, you see the 3. It's right there. Boom. Done. Okay, so, wow, sorry that was more of a mess than I meant it to be. Hopefully you got something from this. So we accomplished exactly what we were going to, which is we set up this REST URL to be able to talk to our Lambda function that talks to our model that was deployed on SageMaker. In next week's video, which is hopefully the last video, not hopefully, but I hope we finish next week, we'll create our beautiful website that has the canvas on it, that draws where you can draw those handwritten images, gets sent to the model through that REST API, and then we get a result back and show it on the screen. Thank you for sticking with me, friends. This is a lot of fun for me. I hope it's fun for you. I hope that you all are learning, or if anything, finding humor in my mistakes. As always, we're happy you're here. Please subscribe to the Facebook Open Source YouTube channel. Check us out on Twitter. Check out my blog post. And feel free to reach out with me for any tips or questions or suggestions. Hopefully the resolution was better. I love interacting with you all, so I'm looking forward to continuing this conversation. Happy Wednesday, everyone. I hope you have a good rest of your day, and I will see you next week. Bye.